Visual Studio Async includes also a new library, TPL Dataflow. Can you explain the motivation of this new library?
Yep. So TPL Dataflow really has its root in, I think, maybe three different places. One is the asynchronous agents library that I mentioned that we have in Visual C++ 2010. Another is the concurrency and coordination runtime, or CCR, for Microsoft Robotics. And another is Axum, which was a language that my team built a couple of years back, a year or two ago. And so we've sort of taken a lot of ideas from all those and built them up into this new system.threading.tasks.dataflow DLL, which we plan to include in future iterations of the .NET framework. The motivation for this is really about making it easier for developers to build parallel applications that have isolated state, that are scalable, that are based on asynchrony and in-process message passing, and more actor agent-oriented models where I can have isolated processing, and all of that processing communicates by sending messages around. Just like with asynchronous agents, you can create these data flow networks where I can create these processing blocks or data flow blocks or messaging blocks, whatever you want to call them, and have them explicitly linked together. So as I send messages to them, that data then propagates through a network with a lot of control from the developer around how much parallelism deploying various stages, making sure that ordering is maintained, fully supporting cancellation, and so on and so on. Also, it integrates very well, and it kind of has first-class integration with the new async CTP support, where you can do things like await data from buffers and not block threads while you're asynchronously waiting for data to arrive. Write processing loops where I can create one of these data flow blocks where I can send messages to it, and it will asynchronously process them using a delegate that's provided, and that delegate can be asynchronous, so it internally can use await, and the block ensures that until that operation is done, no new operations are spun up. Yeah.
It's very similar than C++ code.
Exactly. Yeah, so there are some differences subtle differences in naming, largely because there are different kind of guidelines for naming in C++ versus .NET, but we tried to maintain a lot of the core ideas from both. And from CCR as well. In CCR you see things called arbiter. We don't use that term, but a lot of the same constructs have remained.
Same behavior.
Yeah.
With this new library, is Axum project is still useful?
So Axum's interesting. We've taken a lot of the core ideas from Axum and brought them both into the language and the library. And if you look at this async CTP, in fact, Axum kind of was actually had that feature implemented in a slightly different way, but it served as one of the primary impetuses for bringing that feature into the language. So we kind of took that key aspect of Axum and are bringing it into C# and Visual Basic. Axum also included these concepts of these data flow networks, these coordination primitives, and we're bringing those into the data flow library. So the combination of the data flow library and the support in C# and Visual Basic represents a large piece of what Axum actually was. Now, there are some pieces to Axum that don't show up here, namely one of the biggest pieces is compiler enforced isolation state, so that you couldn't do things that were unsafe, for example.
Yeah. For instance, in Axum is a language I know, but there is a notion of domain.
Yeah.
To share in a specific domain prevent data, for instance.
Yeah.
Do you think it would be a good idea to introduce that?
I think it's a very powerful and useful concept. We have tried to encapsulate some of that into library. For example, in this Dataflow library, there's a type called concurrent exclusive scheduler pair, which allows you to say that tasks or data flow blocks associated with one of the two schedulers in this pair can either be exclusive or concurrent. And the scheduler pair ensures that work is only executed according to that exclusive concurrent semantic. So you can, with some kind of developer-enforced isolation rather than compiler-enforced isolation, you can say that these blocks or these tasks will be reading data, these blocks or these tasks will be writing data. Make sure that if writers are running, no readers can run, and if the readers are running, it's okay for multiple to running at the same time.
This TechEd Europe has been a big event for me. Your session about the future parallel programming for VNext was awesome.
Thank you.
And about GPU and C++, you prepare a new library, oriented data parallel extension for C++. Can you explain the motivation of the future library?
Sure. So I'll clarify slightly, and that is, we've been talking about these data parallel extensions to C++. It's not just library, it's also language. So basically, the idea is we want to make it, again, our kind of motivation is to make it much easier for developers to take advantage of parallelism. In Visual Studio 2010, that parallelism was all about CPU and homogeneous hardware. And moving forward, we want to be able to better take advantage of other kinds of hardware, whether it's GPUs, whether it's clusters or the cloud, and so on. And so this theme continues on of making it easier and easier for developers to do various things. With data parallel extensions to C++, we want to make it easier for developers using C++ to target GPUs. And not only make it easier, because it's typically very difficult today, but also have developers be able to run regardless of what hardware they're using. So write your C++ once. If you happen to just have a CPU, run there. If you happen to have a CPU with SIMD support, so SSE instructions, take advantage of those. If you happen to have an NVIDIA GPU or an AMD GPU or an Intel GPU, basically be able to take advantage of whatever that may be.
I understand. So this new language extension allow me to compute, for example, my data on CPU, if my CPU is better than my GPU?
The goal is that you'll be able to write your C++ code once using this support, and then whatever execution environment you have, whatever hardware you have, will be able to take advantage of it. I mean, that's the ultimate goal.
Okay. So it's very similar of Intel RBB. RBB is same motivation.
Yep, similar high-level goals.
Yeah. For .NET developer, can you hope to have this kind of feature in the future?
I hope so. I think we'll probably start with the native side of things because native developers are the ones that are currently most clamoring for this support, and also typically like kind of the more pedal to the metal, floating point computations that GPUs are very good at. I do hope in the future we'll see .NET support. In fact, Microsoft Research has a project called Accelerator, which they have a V2 of now, which has both native and managed support, where the managed is actually implemented as a layer on top of the native. I wouldn't be surprised if in the future we saw a managed layer built on top of this C++ support.
Well, I would like to say thank you very much.
Thank you.
It was great for me.
Thank you.